Hi guys, in this video I am going to discuss to you how to solve logarithmic equations. Okay, so let's start with the first example. We have logarithm of 3x to the base of 2 equals logarithm of quantity 2x plus 7 with the base of 2. So as you can see, we have the same logarithmic expressions, the same base. So we can now just cancel logarithm, then copy this 3x and 2x plus 7. So we have 3x is equal to 2x plus 7. And so we can now solve 3x minus 2x is equal to 7. So 3x minus 2x is x equals 7. Okay, so this is the solution for this logarithmic equation. Okay, second example. How about logarithm of quantity 2x minus 4 with the base of 6 plus logarithm of 4 with the base of 6 equals logarithm of 40 with the base of 6. So as you can see, we have addition. So we know that one property of logarithm is logarithm of product, such that logarithm of a times b with the base of x, let's say, is equal to logarithm of a, the base of x, plus logarithm of b, the base of x. This is the logarithm of product. So we can use this to simplify the left side of the equation because we have an addition operation. Okay, so therefore this left side can be written as logarithm of 2x minus 4 times 4 with the base of 6. So applying the logarithm of product, then equals logarithm of 40 with the base of 6. So we can multiply first. We have 2x times 4 is 8x. Then negative 4 times 4, negative 16 equals logarithm of 40 with the base of 6. So we can now cancel logarithms. Okay, just put 6 here. We can now cancel logarithm, then copy 8x minus 16 is equal to 40. Then solve for x. We have 8x equals 40 plus 16. So negative 16 will be transposed to the right side. It becomes plus 16. Then we have 8x equals 40 plus 16, 56. So divide both sides by 8. Therefore, x equals 56 divided 8, 7. So the answer is 7. Okay, another example. How about logarithm of x with the base of 2 plus logarithm of quantity x minus 3 with the base of 2 equals 2. So in here, we can use also the logarithm of product. We have logarithm of x times x minus 3 with the base of 2 equals 2. So you just multiply x and x minus 3 because we have addition. So, and then we have to simplify first. We have x times x, x squared, x times negative 3, negative 3x equals 2. So how we are going to solve for x? So in this case, we are going to transform this into exponential form. We have base, then the value squared equals this, x squared minus 3x. So we have 2 squared equals 4, then equals x squared minus 3x. And then this is quadratic, so we have to equate this to 0. We have x squared minus 3x transpose 4. We have minus 4 is equal to 0. Then we can solve the equation by factoring. We have x plus x minus, because the last term is negative and the middle term is negative, so therefore we can assume that the larger number should be negative. So what will be what numbers to be multiplied that will give us negative 4, and when we add, we have negative 3, and that is negative 4, 1. Okay, because negative 4 times 1 is negative 4, then negative 4 plus 1, negative 3. Then solve for x. We have x plus 1 equals 0, so x is equal to negative 1. Then x minus 4 equals 0. Oh, sorry, minus. Then x is equal to positive 4. So there are 2, but we have to check. Okay, look at this value. X equals negative 1. When x is negative 1 here, log of negative 1 with the base of 2, this is undefined because logarithm exists only for positive real numbers. Okay? So therefore, we can say that negative 1 is an extraneous solution. And the solution for this equation is only x equals 4. Okay, so the answer is only x equals 4 because x equals negative 1 does not satisfy the given equation. Okay, next. How about logarithm of x equals 1 plus logarithm of 22 minus x? So as you can see, the base of the logarithm is not visible. This means that the base is 10. This is a common logarithm. So what we are going to do is to combine all logarithms in one side of the equation. So that will become logarithm of x, then transpose this to the left. So minus logarithm of 22 minus x equals 1. So since we have minus, if the operation is addition, we have logarithm of product. But when the operation is subtraction, we have logarithm of quotient, and that is equal to logarithm of x divided by 22 minus x equals 1. Then to solve this equation, we have to transform this to exponential. So as you can see, the base of the logarithm is 10. Okay, so that becomes 10 raised to 1 is equal to x all over 22 minus x. Then 10 raised to 1 is 10, so we can now solve this equation by cross multiplying 10 times 22 minus x. So 10 times 22 minus x equals x. Then distribute, we have 10 times 22 is 220. Then 10 times negative x is negative x, or rather negative 10x equals x. Then combine similar terms. So we have 220 equals x. Negative, bring it to the right side, becomes plus 10x. And that is 220 equals 11x. Dividing both sides by 11. So cancel this. So we have x is equal to 220 divided by 11. That is 20. So the value of x is 20. Okay, last example. How about for natural logarithms, or ln, natural logarithm of x plus 2 equals 32. So if we have natural logarithm, the base is e. Okay, so how we are going to solve for this? We have 4 ln x plus 2 is equal to 32. So we divide both sides first by 4. So divide both sides by 4. Okay, so we have cancel. We have ln x plus 2 equals 8. Then transform to exponential. The base of this logarithm is e. So therefore we have e raised to 8 equals x plus 2. So how we are going to solve for x? So this is constant. We do not have variable here because e is a number whose value is 2.71828 approximately. So to solve for x, we transpose 2 to the left. Therefore we have e raised to 8 minus 2 equals x, and that is equal to approximately, use your calculator, that is equal to approximately 2978.96. So the value of x in this equation is 2978.96. Okay, so this is the process on how to solve logarithmic equation.